Hey everybody, this is Roto Motion and Douglas GB starting season 1, episode 5. Douglas is going to lead this discussion. This is going to be a little bit more advanced. The last time we did the RAM test tab, this time we're going to be focusing on the vector generator test. So get your vector boards out because here we go.
Yes, the mystery of the vector state machine, and Fred has done a great job in this vector generator test with its four sub tabs. And we're going to go over the standard tests. And the first one is always the halt test, and the reason is that is the simplest thing you can have your vector state machine do for you. It you're telling it to stop essentially. um, so real quick overview of this screen. You have your choice of tests here from this drop down, and then the button that lets you run it, and then tells you what's happening or what has happened. Um, and then this box over here is the actual vector instructions that you just ran. So the halt test, you really only need one halt command, but I guess it's for good luck that you have several. You really could just do one. You cannot change this. This code is provided by Fred according to the test that you choose here. So if we run the center test, then you see, that is automatically filled in. You cannot change it. You don't need to change it because it comes that defines the test.
So
Uh,
Douglas,
mm-hmm.
I apologize for interrupting you. Explain why would I even run these tests?
Well, if your board is not working, a vector board, you have your game side run by the 6502 or 6809 if it's Star Wars. That handles all the game side of things like coins and buttons and joysticks, what have you. But then for all the drawing, those processors can't do it fast enough. So Atari, this is like having a second processor on the board whose job it is to retrieve the drawing commands, and then execute the drawing commands. And so the CPU fills up vector RAM with instructions on what to draw, and then it says, okay, vector state machine, go do it, because I'm not fast enough to do it. You do that, and when you're done, tell me. Light up this halt button, and I'll know that you finished what I asked you to do, and then it'll be my turn again to figure out what we're going to do next. And that's like tick tock all the time happening, uh, back and forth.
Oh, so I understand. So if I have a vector board and I have gone through, like we mentioned in previous episodes, and run a ROM test and a RAM test, and they're good, this could be or should be my next area to explore.
That's right. Yeah, the ROM and RAM, uh, those are those are from the CPU's perspective. Some of the ROM is used for vector stuff, and some of the RAM is used for vector stuff. But when you test them, you are testing them from the CPU's point of view, which is, like I just said, the CPU can put instructions into vector RAM, but then it's the vector generator that then uses that follows those instructions. So yeah, if everything is checked out from the program side, or this from the CPU's perspective, this is now getting into the other side of the board and the VSM.
Okay, so can you help me out in point on the schematic? You kind of talked about almost a secondary processor for the VSM. Where would that be?
Yeah, this is Space Duel, and you can see up here is the main CPU, 6502, and right, it goes into program ROM, program RAM. This is where it stores, this is where it does its work. Um, and these are all the inputs, but then you get down to here where you start getting into the vector side of things. Vector RAM, vector ROM. This is like the little shapes of the spaceship or the UFOs or what have you are in vector ROM. Vector RAM is more dynamic, where those instructions are stored based on what's happening on the game. Like what do you need to draw at any given time? One spaceship or two? How many enemies? This is all the instructions the CPU puts into vector RAM is what gets drawn. But then to answer your question, and this is the beginning of, these are kind of the outlying regions of the vector state machine, but this is the main brain. This little chip here, it's called a PROM for programmable ROM. You can't erase it. You can only program it once. It's already programmed, and this is the one that has the Atari logo on it. And for Space Duel, it'll be like 1360. Actually, for almost all the vector games, they're the same. The three early ones are different, but then everything from Battlezone up to everything past Battlezone is 136002 is the Atari part number. Now, there's an exception to that, which is Star Wars. Fred has found out is slightly different, but anyway, this very chip N4 is the location on Space Duel, but that same programmed chip is the heart of every vector game.
It's very, very interesting. Thank you.
And what it does, is, like any other memory chip, it has address lines coming in, and then I'll call these data lines going out. So it's a very simplified processor, but what it does is take in certain bits on the left-hand side, and it is programmed inside to respond to whatever combination of bits comes in over here. It then outputs a certain sequence of 4 bits over on this side. So so we're kind of getting off of the standard testing, but it's good background to know what you're testing. What these tests do are issue commands by way of sending certain bits into that left-hand side of the chip, and then it measures how long it takes the thing to do what you've asked it to do. So, like the halt test, if you run that, you should get about 2.4. 2.2 is, this is a working board that's hooked up to, because that's how long it takes this system to execute this program. I can run it again, and you can see, like, this is the most recent value, and then when you run it again, that gets shifted down to the lower box, so you kind of have a history like you just saw there. That was the new reading, and then it went down to the second reading.
So I had a broken Space Duel board, and it had a bad halt, and I would run the halt test, and sometimes, and right now I can see the status says done, but mine would say error, and my hold switch would be totally different than what is up on the screen right now. That basically tells me that test didn't pass.
That's right. Yeah, and this is the first test I would always run because it's the simplest, and later tests kind of build on. Well, every program ends with a halt command, again, so that when the VSM encounters the halt command, that's the last thing it does, and then it turns on this little light, which the CPU. This is the CPU's perspective on the vector state machine. And the CPU monitors this like as if it were any other input, like the fire button or the rotate button. It monitors the VG halt signal, and when it's active, the CPU realizes, oh, the vector state machine finished what I asked it to do, and now I can take my turn. And that's what these are doing, is measuring for any given program that you tell the VSM to run. It measures how long it takes for the halt light to come back on. Because when you run it, well, that's not fast enough. But if we do a longer vector program, you can actually see. Well, maybe you can't see it, but if it were long enough, this light would go out while the vector state machine is busy, and then the light would come back on when the vector state machine is done. Yeah, maybe it doesn't update, but that's what's actually happening. And you can, as you said, John, if something goes wrong, then your VG light may go out, in which case your board will sit there doing nothing. And that is a common problem of a non-working vector board. If you have tested your RAM and ROM and everything's fine, but yet it still doesn't work, it's because your vector state machine is not able to finish what your CPU has told it to do.
So I'm a tester like you are, Douglas, and I must be on a different version because you have verify, loop, reset after test. Why would I use those?
Yeah, this is software version 2.0 that came out very recently. This is February 2nd. We're recording this. Loop it will just keep running a test. So, for example, if you're what's a good one? Center. Well, easy one. Reset after test. If you run a test and the halt light turns off and never turns back on, then you could go to reset and run that just to light it back up, just to halt the runaway vector state machine. But this is a little shortcut to just turn on this. So that will, after your test is run, even if it times out and the board is spinning in some unknown state, it'll reset it after a certain amount of time. So that just saves you from a couple steps.
So a practical way of combining the test and using reset and loop could be that I would like run VG reset or excuse me, VG halt or VG center and loop it and then reset it after the test, and that gives me the opportunity to remeasure it without having to go back into the program. That's a good way of using the screen, right?
Yeah, so right, so loop, you can see it's just running that same test over and over again.
Mm-hmm.
I'm trying to think of a way we could get that to, oh, here, if I jump to a certain address, there you go. So look at the code over here. You don't have to be a programmer to see this, but it does a center command, and then it jumps. This command means jump to subroutine, but where is it jumping? It's jumping back to the beginning of this program. It's jumping to 0, which is here. So really what I've created here is an infinite loop. So my vector state machine is trying its hardest, but it's stuck running just these two commands and never gets to halt. So that's why halt doesn't, I'm stuck. I'm like stuck now. So that's a good example. If I reset after test and run this, then it is still broken. It is still, my program is faulty in this case. It's not my hardware, it's my software. But the reset after test saves me. And how do you then know that it was broken? Because instead of saying done, it says, hey, your halt never came back. I've reset the board for you, but the results of running this test were not good.
That makes perfect sense.
I think that's going to be it. This video is already kind of long. We didn't get very far, but we did a lot of theory. I think we'll break this up and do another video where we continue.
Can I put one more thing, Douglas? The pulse width signal, or are we thinking about it? That would be best in a later video.
Yeah, let's demonstrate that again. That's the time it takes for the state machine to do its thing and then say, hey, I'm done, I'm halted. And that's why when I run this program that never completes. That's why you get infinite amount of time, because it never finished. If you run a proper test, then you get a certain amount of time, and those times are known, which is kind of the backbone on which this whole vector generator test tab is built, which is, these no matter what the game, the vector state machine is similar enough from Battlezone onward, and it's also the digital vector generator on Lunar Lander Asteroids and Asteroids Deluxe. They are consistent enough that running this program on really any of them will always execute in about the same amount of time. So that's why that's why we know this time 89.6. Who came up with that? Just empirical testing, measuring. Run this program, measure the time between when you say go and when halt comes back and says I'm done. It's about this long.
Makes sense.
All right. We'll come back at you with another episode because there's lots more to see here.
We'll see everybody later.